Hi guys, welcome back to my channel. Sorry for not posting for a while, but here I am. Refer to the tables below to answer the questions at the right. The growth of various plants is recorded over a 4-week span. Which plant has growth that could be modeled using a linear function? Now linear, that means we're going to have a common difference. So we're going to be adding or subtracting the same number. Okay, now this second question says which plant has growth that can be modeled using exponential function? That means we're multiplying or dividing by the same number over and over again. Okay, so let's start with the linear. I'm going to look at the tables here. So first of all, I notice in all my tables, my weeks are going up by ones. Now for my heights here, 1 to 2, that's going up by 1. 2 to 4, that's going up by 2. So this is not a constant rate of change. I'm going up, I'm going to be multiplying by 2. Then 2 to 4, you multiply by 2 again, and multiply by 2 again. So this isn't linear, this is exponential. So we're going to say plant 1 is exponential, okay? Now, plant 2, we have 4, 7, 10, 13. Am I adding by a certain number? Yep, I'm adding by 3 each time. So that means this is linear. So plant 2 is linear. Plant 3, I'm starting with 2, I'm going to 3. So I'm going up by 1. Then I'm going from 3 to 4.5. This doesn't go up by 1, so it's not linear. But this actually is exponential. So if I wanted to find the common ratio for this, I get 1.5, right? You're actually multiplying by 1.5 by each. You can test it yourself. 3 times 1.5 is 4.5. And then 4.5 times 1.5 is 6.75. So this is also actually exponential. Plant 4, this is going up by 0.1, then we're adding on 0.6, and then we're adding on 0.2. This is neither. This is neither. There is no common difference and there is no common ratio. All right, because even if you were to divide, it doesn't work out. Okay, so this is number 1. So linear, you're looking for a constant rate of change. Exponential, you are trying to see if you're multiplying or dividing by the same number over and over again. Okay. Which situation would not be modeled by an exponential function? So there's a couple of things that jump out. Not be modeled by an exponential function. So if it's not exponential, let's see which one is linear. Now linear means constant rate of change. Okay, which one has a constant rate of change? Population of a species of fish halves every 5 years. It's halving every 5 years. The same number isn't taken off, so it's just halving. That would be exponential, not linear. Pull deposits $12.50 in a local bank that will earn 1.5% interest. That's another keyword for exponential. So these are E, this is E. 3, a certain type of sunflower grows at a rate of 4 inches per week. That's a constant rate of change. That's linear. And let's see. A species of ant triples. There's a word, triples. That is exponential. Okay? So that would be linear for 3, which would not be modeled by exponential. 3 is the only one that would not be exponential. So it's going to be like the opposite for number 3. Which statement could not be modeled by a linear function? So we don't want a constant rate of change. We want something to double, triple. We want interest. All right? So now here, the population of a species of deer grows by 500 every year. So if it's 500 every year, this means this is actually linear. This is linear. So no, we want not to be modeled by a linear. The water is draining from a pool at a rate of 6 gallons every 10 minutes. Every 10 minutes, 6 gallons is coming out. This is linear. John saves $200 per week. Same amount every week. It is linear. Emily deposits $500 in a local bank that will earn 2.5% interest every year. That is exponential. All right. So this is not the only one that isn't linear is 4. Joke, Miss Heschel. So yeah, the graph of the function f of x equals the square root of x plus 2 is shown. Is it shown though? It's not really shown. So guess what? I'm going to have to just quickly draw that in. Okay, so it looks like this. What's the domain of the function? Now, quick thing, all these should have or equal to signs underneath it. For the domain and the range. My bad. Domain of the function. What's my first x value? All right, my first x value is right over here. So that's -2. So right now your domain is starting at -2 and it's going to the right. This should match your symbol here. Okay, so it has to be like this symbol right here. So it has to be choice 2. The range of the function is, what's your smallest y value? So this point right here, that is the point -2, 0. This is your x for your domain. This is your y for the range. So it has to be y is, now all these numbers are bigger than, greater than or equal to 0. So this is going to be choice 1. Okay, so domain and range. Always see where you're starting off. Oops, where you're starting off. What's your starting point? Take that coordinate. That will help you out with your domain and range. In comparison with the graph of f of x equals x squared, the graph of g of x equals x plus 4 squared minus 6 is a result of translating. Another word for that is transformation. So that's like, what's the shift? So if you had a coordinate plane, f of x is chilling in the middle. It's the parent function. If you graphed this in your calc, what you would have is something that is moved over to the left and shifted 6 units down. So you'd have something that looked like this. Okay, so the effect is we're going to the left 4 and down 6. Choice 4. The graph below models the height of a remote control helicopter over 20 seconds during flight. Over which interval does the helicopter have the slowest average rate of change? So the slowest, normally we want the steepest. What is the flattest section? So to be honest with you, I can narrow it down to 2 places. I could be either this or this. So we're going to section it off. All right, we have 5:19. So from 5 to 10 hours or seconds, excuse me. So I'm going to do my y2 minus y1, 20 minus 19 over 10 minus 5. I have 1 over 5. That is 0.2. That is an average rate of change of 0.2. Now my other one is from 15 seconds to 20 seconds. So let me copy those points down. 15, 14, and then 20, 17. So now I'm going to do my y2 minus y1, 17 minus 14 over 20 minus 15. So this is 3 over 5, which if you put that in your calculator, 0.6. Which one's smaller, 0.2 or 0.6? This one, right? So this is from 5 to 10 seconds. So that's choice 2, 5 to 10 seconds. All right. Which functions have the, which statement is true? Look at all these choices here. Whoop. Let me just get in there a little bit more. Can I? All right, so here. Which statement is true? Y-intercept for h of x is greater than the y-intercept of f of x. Let's find the y-intercept for each one. Now, y-intercept is where your x equals 0, the y value. What's the y value when the x is equal to 0? So over here, it's super easy to see what the y-intercept is. The y-intercept is 5 for h of x. the y-intercept, and also it's right here, right? The y-intercept for f of x is 1, okay? Now, if I was to put this in the calculator and look at my table, what I would get is that my y-intercept is 2. My y-intercept is 2 for that one. So, g of x is 2, h of x is 5, f of x is 1. There's technically 2 choices that works for this. The y-intercept for h of x is greater than, so h of x, we have 5. Is 5 greater than f of x? Yeah, that works. The y-intercept for f of x, 1, is greater than the y-intercept for g of x, 2. Is 1 greater than 2? Nope. The y-intercept for h of x is greater than both g of x and f of x. So remember, h of x is 5. Is that bigger than both 1 and 2? Yeah. The y-intercept for g of x is greater than the y-intercept for both. 2 is not greater than 1 and 5. All right, so that's a no. Okay, so y-intercept is where the x is 0. What's your y value when x is 0? Right down here, you're going to graph the function. So we have, to put this in our calculators, now the first thing that's going to pop up, you're going to have 1, 2. Okay. The next point you're going to have is 2, 3. Now you're only going to take the whole number points. So the next one is going to be 5, 4. And I'm pretty sure that's all that we can fit. Let me just check. We also have 10, 5. So let me just graph this real quick. 1, 2. 2, 3. 5, 4. And 10, 5. So that looks like this. Right? That's it. That's it. You're just graphing it. Determine the first 3 terms of the recursive sequence defined below. Hey-oh, where is it? Oh, here it is. Okay. So we want the first 3 terms. First 3 terms. Now that's easy. We got our first term is 0. Now the rule is telling us you take 2 and you're going to multiply by the previous term. That means the previous. So the previous is 0, and then we subtract 3. So 2 times 0 minus 3, that's negative 3. That's your value of your second term. Now to find your third term, you're going to set up yourself the same way, 2 parentheses. Oh no, I forgot an exponent. So how does that change my answer? 2 times 0 squared minus 3, that's still going to be the same stupid thing. Yay! So we have negative 3. Thank goodness. So now we're going to put negative 3 in here for the previous term. And subtract 3. So you get negative 3 squared is 9. 18 minus 3, that's going to be 15. So your first 3 terms should be 0, negative 3, and 15. Okay? And then last but not least, I know this has been a long one. A car was purchased for $25,000. Uh-oh. I feel a growth or decay problem coming on. Research shows that the car has an average yearly depreciation, is that growth or decay? We're going to be decaying, going down, rate of 16.2%. Create a function that will determine the value v of t over t years. So we said this is decay. The formula for decay is y equals a times 1 minus r to the t, or to the x, okay? Now, my y is v of t. My a is my initial value. My initial value is 25,000. 1 minus. Now my R has to be as a decimal, 16.2 as a decimal. Move it over 2 places to the left. So you're going to do 1 minus 0.162. Okay, and now this variable has to match with the exponent. So we're going to put a t up here. Okay, that is your equation. This is decay because it's depreciating, it's going down. Determine to the nearest cent how much the car will depreciate from year 3 to year 4. So let's find how much. So we want to find out how much it's going to be worth at year 3. What we're going to do is plug in 3. So we're going to say t equals 3. So v of 3 is going to be equal to 25,000 times 1 minus 0.162 to the third power. We're going to find that out to the nearest cent. All right, then we're going to find year 4. Now it's going down, so if you have that, since the value is going down, you should have for year 4, it should be worth less money. So you're going to plug in 4. So we're going to get those two values. So to the nearest cent, this is $14,712, it's a comma, and 1 cent. Okay, so that's for 3 years. Now after 4 years, it's going to be worth, I'm just putting it in my calculator, it's going to be $12,328.67. Okay? Now, you should see that it's going down from year 3 to year 4. Now we want to find out how much the car will depreciate. So what's the difference? To find the difference, you're going to do $14,712.01 minus $12,328.67. And what you get is a difference of $2,383.34 between the years. So that's a lot to go down, right? It goes down almost $2,500 between years 3 and 4. All right, guys, so that's the review. I hope this helped. If you have any other questions, let me know. Test is tomorrow. Have a great night. Bye.